Very good morning, students. Let us see n-bit parallel subtractor. You understand what is parallel subtractor? Parallel, it is going to subtract bits. Okay, the function of parallel subtractor is to subtract two n-bit numbers. What do you mean by two n-bit numbers? Suppose I want to subtract a and b, that are two numbers which are n-bit in nature. A can be a0, a1, a2, a3. B can be b0, b1, b2, b3. If a is a0, a1, a2, a3, for example, a is 1101, b is 1111, then I call it as 4-bit. Okay, so I need to use 4-bit parallel subtractor. So what is the job of parallel subtractor? Parallelly, it needs to subtract two bits to n bits. Clear? It is going to subtract two n bits. The value n depending upon the number of bits in A and number of bits in B. Clear? So A can here in this case A has 4 bits, B has 4 bits. Then I need to use 4-bit parallel subtractor. How am I going to subtract? I am going to subtract using 2's complement method. So I want to do A minus B. So what is the 2's complement procedure? A is added with 2's complement of B. Okay, the procedure to subtract A minus B using 2's complement is A is added with 2's complement of B, or you can write it as A plus what is called as 2's complement of B. First we need to take 1's complement of B and add 1 to the 1's complement of B. So I can write it as A minus B. Subtraction of A and B can be obtained by adding A with 1's complement of B plus 1. Okay, so n-bit parallel, this should be subtractor, n-bit parallel subtractor needs n full adders. That is very important. Here we are obtaining subtraction with help of addition. I repeat, we are obtaining subtraction with help of addition. That is why we need, instead of, it should be n-bit subtractor. Subtractor needs n full adders. In this case, can you see I am going to subtract 13 minus 11. 13 in binary is 1101. So 13 belongs to A. I am going to subtract two numbers. The two numbers are A and B. A is 4 bits, 13, that is 1101. B is 11, that is 1011. So I need, how many bit subtractor? I need to count the bits, 1, 2, 3, 4. I need 4-bit parallel subtractor. You know 13 minus 11 is 0010, which is 2. 13 minus 11 is 2. But how actually we do? We always add 13 with 2's complement of 11. So to find the 2's complement of 11, what is that I need to do? First I need to find 1's complement of 11. What is 11? 1011. So find the 1's complement of 11. Add 1 to 1's complement. So you get 2's complement. For 0101, I have added 1 so that I get 0101. Okay, now what is that I am going to do? I am going to add A. What is my A? 13, 1101 with 2's complement of 11. What is 2's complement of 11? 0101. Okay, if I add it, 1 plus 1, 0, carry 1, 1. 1 plus 1, 0, carry 1. 1 plus 1, 0, carry 1. Ignore the carry, you get 0010, which is nothing but 2. Clear? So how are we going to do? It is very clear that to perform subtraction we need adder, addition. Okay, so I'm going to use, since we have n-bit parallel subtractor, I use n full adders. So there are n bits. So I'm using n full adders. Can you see full adder 1, 2, 3 till full adder n? Okay, the first one, A. What is the formula? A minus B. How am I going to get A minus B? A plus 2's complement of B. What is 2's complement of B? 1's complement plus 1. How will I get 1's complement? I invert B, all the bits of B using NOT gate. Okay, so A1 remains same. 1's complement of B is obtained by taking, by connecting a NOT gate to the B, so that I get input is B1, output here is 1's complement of B1. So have I achieved this 1's complement of B? Now how am I going to achieve this plus 1? plus 1 is achieved by this carry. So I need to make this carry as 1. If I make this carry as 1, what happens to the full adder? Full adder will add, will add A with 2's complement of B. How am I going to achieve the 2's complement of B? First I take B, invert it so that I get 1's complement of B, add that 1's complement of B with this carry so that I get 2's complement. So the 2's complement is added with this A. So the output finally a full adder is a sum and a carry. So I get sum here. Now carry is propagated from one stage to next stage. Carry out of first stage would be carry in of next stage. So how am I going to do my second stage? My A2 remains same, but my B2 has to be going through the NOT gate to get 1's complement, add it with C2 to get 2's complement, so that I do this process. So this process is propagated. So what is the outputs S1, S2, S3, S4? The outputs, all this S1, S2s are the subtraction outputs. If there is any borrow, that comes out in this C out. This is how we are going to perform the full subtractor or n-bit parallel subtractor. If you want, in this place, you can write 4-bit parallel subtractor and use FA1, FA2, FA3 and FA4 and leave it. In the exam, if they ask 4-bit parallel subtractor, use only 4 full adders. Since it is n-bit, I have shown an example of n bits. So here, very clear 2 points. First, subtraction is obtained by addition. So you are using full adder. How are we going to add it? We are going to take A minus B is obtained by A plus 2's complement of B. So 2's complement is obtained by 1's complement plus 1. So 1's complement of B is achieved by this NOT gate. Plus 1 is achieved from this carry. So C1 should always be 1 because 1's complement plus 1 will be 2's complement. A is added with 2's complement of B so that I get my output of the first stage along with carry. Output of first stage would be input of second stage. This is how it is going to propagate. This is the description of n-bit parallel subtractor. Thank you.